Okay, in this lesson, we are going to talk about motion. Okay, we talked about it in class. Motion is when an object changes position over time relative to a reference point. So, what's a reference point? Remember, we talked about it in class. It's that object that appears to stay in place so that you can tell that something else is moving. Now, remember that word appears. Appears means that it appears to stay in place, but remember, everything really is moving. The earth is always moving. Okay, we're going to talk about three important ways to measure motion today. First one is speed. This is the distance traveled by an object divided by the time taken to travel that distance. So, you've heard of speed before. You've heard of speed limit. So in order to find the speed, you're going to use the formula distance divided by time. So let's look at an example. An athlete swims a distance from one end of a 50-meter pool to the other end in 25 seconds. What is the athlete's average speed? So in order to find the swimmer's speed, we're going to use our formula, distance divided by time. So when we look back on our problem, we see the athlete swims a distance of 50 meters, and they do this in 25 seconds. Whenever we divide, as the formula asks for, we see that the swimmer's speed is 2 meters per second. We'll take the meters from the top and the speed from the bottom in order to write out our unit. Okay, example number 2. A little kitten traveled 600 meters in 20 minutes. What was the kitten's average speed in meters per second? So if you look here, got a little trick question here. So you're going to need to know how to convert. This is going to be very important. You are going to need to know this information for the test as well. So we're still going to use the same formula. Speed is equal to distance divided by time. But we see here that we are given the minutes, but we want to know, the question is asking for the speed in seconds. So let's go ahead and just start plugging things in of what we know. We know that the little kitten traveled 600 meters in 20 minutes. Before we divide, you need to know before we are going to divide, we need to convert our minutes into seconds because we want meters per second. We have meters per minute. We want meters per second. So let's take our 600 meters divided by 20 minutes, and let's convert. We want meters, so we're going to leave that the same. But in order to change minutes to seconds, we have to multiply by 60 because there's 60 seconds in a minute. So now we have 600 meters because that doesn't need to change, and 20 minutes will now be 1,200 seconds. When we divide, we get 0.5 meters per second. We wanted seconds, now we have it. Example number 3. Greg decided to work on his running skills. The first time he ran, he traveled 30 minutes. If Greg ran 2,800 meters in that time, what was his average speed in meters per hour? Another trick question, so let's work on this converting. Let's go ahead and write down what we know. Distance over time. We know that Greg ran 2,800 meters in 30 minutes. But we don't want meters per minute. We want meters per hour. So we need to convert. So let's take what we know. We want meters, so remember that will stay the same. But what is 30 minutes? How do we convert that to an hour? Well, think about what 30 minutes is. 30 minutes is a half of an hour. So in order to write that, meters is the same, and 0.5 hours is the same thing as 30 minutes. So now we have what we want. We want meters per hour. So when we divide, we get that speed is equal to 5,600 meters per hour. Okay, so sometimes you may not only have to find out the speed, you may have to find out the distance or the time. So here is a wonderful tool. This is called the speed triangle. So if you want to find out the speed, which we already know the formula, we cover up this S, and you'll see that distance, this line is going to be divided by time, is your formula. Okay, so this line means division. This line means multiplication. So if we want to find distance, we cover up our D. So distance is going to equal speed times time. Well, what if we want to find time? You cover up the T, and what's left? Distance divided by speed. Let's see how we can use this. Okay, so Juanita cycles at an average speed of 7 miles per hour. If she cycles for 5.5 hours, how far does he travel, or she? So we are looking for how far. What is far? That is distance. So what formula should we use? If we go to our speed triangle, we're trying to find distance, so let's cover up our D. And what we have left is speed times time. So let's use our formula. So what do we know in our problem? We know that distance is what we're looking for, speed is 7 miles per hour, and time is 5.5 hours. So we have miles per hour and then hour. So whenever we do this, we see that the distance that Juanita travels is 38.5 miles. All right, example number 5. Now we want to calculate time. So Emma drives at an average speed of 45 miles per hour on a journey of 135 miles. How long does Emma's journey take? So we're looking for time, so let's go to our speed triangle, cover up our T, and what is left? Distance divided by speed. Okay, so now we plug in what we know. We know that the distance is 135 miles. We know that the speed is 45 miles per hour. When we divide, you will see that the time it takes is 3 hours. Okay, so 2 other important things that we are going to talk about that you're going to have to calculate for your test is velocity. Now, I'm going to just go ahead and tell you velocity, that is the same thing as speed, except we're going to add a direction. So, same formula, add direction. So, velocity is equal to distance divided by time. Okay, so let's calculate the velocity of a mountain climber if that climber is moving northeast at a pace of 1.6 kilometers in 1.4 hours. Alright, so let's use our formula. Same thing as speed. We're just going to change one thing, and that is to add a direction. So we see that the distance is 1.6 kilometers. The time is 1.4 hours. When you divide, you get approximately velocity is 1.14 kilometers per hour, and this is northeast. This is what makes a velocity right here, is that direction. Alright, one last example. Another way to measure motion is acceleration. This is the rate at which velocity changes over time. So here's the formula. Acceleration is equal to, this triangle means the change in velocity over the change in time. So how much the velocity changes divided by how much the time changes. So let's go over it. A roller coaster car rapidly picks up speed as it rolls down a slope. As it starts down the slope, its speed is 4 meters per second. But 3 seconds later, at the bottom of the slope, its speed is 22 meters per second. What is its average acceleration? So let's use our formula. The change in velocity, and this is supposed to say divided by, the change in time. So, Let's look at the problem. How much did the velocity change? Now remember, velocity is the same thing as speed, except there is a direction. So if you see, it starts at 4 meters per second, but it changes to 22 meters per second. So how do you find the change in something? How do you find the difference? You subtract. So we're going to do 22 minus 4 to find out that change in speed or velocity. And then it tells us the change in time, which is 3 seconds. So 22 minus 4, which is our change in velocity, is 18. The time is still 3. So to find the acceleration, the change in velocity over the change in time is 6 meters per second. Well, how do you clean that up? You're going to write acceleration as this problem, 6 meters per second squared.